So far everyone is good, right? Whatever we have done so far, okay, everything with the practice. I'm saying the hands-on part, okay. Any challenges, anyone, right? So far, right? Whatever we done, right? Hive, scoop, H-base, Flume, we done, right? Everybody is good. So PyCharm, what you need to do, you have to download the community edition. You have to go to PyCharm. This link. Here you will get it. Okay. So if you are doing for the Linux version, so download this one, Linux star file. Okay. Download this one in Ubuntu. Okay. This is the link. Okay. Download this one and extract this one. Same like I did here. Okay. So yeah. So here, if you go to the PyCharm, so when you extract it, you will get it like this. Okay. I got it. It is good. Okay, so I go to 3D softwares, PyCharm, and bin. So here is pycharm.sh dot slash pycharm.sh. So I will start my PyCharm. Okay, and other one is a Spark, right? You download the Spark 3.2.3 or 3.3.4. So yesterday I showed you the options. So once you download the Spark and set the home path and bin path of the Spark. Okay. So this is the PyCharm. And if you are starting the Spark on the terminal, so we can start the PySpark. So I will type PySpark. So let's start the PySpark session here. Okay. So when you want to run any program, right, in your terminal, you can run on the PySpark shell. Or if you want to run in editor, you can run editor. Okay. The only thing is you have to configure in the editor, you have to set these two library, py4j and PySparkj. So these two libraries you have to set in your project. Then you can use the PySpark code. You can run any PySpark application you can use, okay, in the PyCharm. So where you are using Spark Session, Spark SQL, Spark Core. Yesterday we were discussing, right, how many libraries are there? Spark Core, Spark SQL, Spark Streaming. So how you can write Python code, okay? So this is all Python code, and this is easy to understand Python code, right? This is all import statement, and this is the Spark session, right? So I will explain it first. What is a Spark context, Spark session, how to create a Spark application, okay, and what are the transformation and actions. So we have to go through one by one all the transformation and action. So we will see first Spark core. So let's start some theory part, and then I will go with the some transformations. Okay, okay, okay. Let me start some. So yesterday we were doing. Okay, so yesterday we were talking about this RDDs, data frame and data set. Okay, so now next we have to look at RDDs, data frame and data set. So mostly we will be working on the RDDs and data frame. Okay, so first we see some more fundamental concept. Okay, that is a Spark architecture related concept. Okay, so we have seen how many modules are there total? 5 modules. So Spark core is a base module, and it is using base module, and it is using all core transformations. Okay, transformations and actions. Okay. So yesterday I talked about there are the two types of transformations, wide and narrow transformation. Okay. This question people ask question like, and what is the difference between the transformation and action? So these are the two different types of functions are there. So there are two types of functions in Spark. Okay. So one is called transformations and another one is action. Okay. So when I differentiate like transformation with action, so transformation is a conversion of your RDD into one form to another form. Okay. So if I say I have got one RDD, and I apply the filter transformation, okay, or map transformation, filter transformation I apply. So I got another new RDD. Okay. So this RDD will be narrow, right? Because if I say, if I have a data of all cities data I have, all cities data, okay, one RDD with all cities. When I apply filter for one city, okay, one city filter I'm doing, one city. So in the new RDD, how many cities data will be there? Only one city data there, right? One city data, right? This RDD, new RDD will be one city data. So this is conversion, right? If you see, you have the RDD of all cities is converted into the new RDD for one city data, right? So if I say, if here are the 100 records are there in this RDD, suppose 100 records, and I say, after filtering the one city data, suppose I say one city has one city has only 10 record. Okay. So how many record will be coming here in the new RDD? Obviously 10 record only will come because we are filtering for the one city. So it means my 100 records filtered into 10. Okay. So this is the conversion of your one RDD to another RDD. So RDD, the transformation is basically a kind of operation. So we can say functions and operations, both are same. You can say what are the different two types of operations in Spark. So transformation is like generating a new RDD. When you are doing any transformation on one RDD, it will create a new RDD. Transformation is a kind of conversion of one RDD to another RDD. So new RDD, you cannot, RDD is fault tolerant, and RDD is a fault tolerant, and RDD is a immutable. So immutable means you cannot modify existing RDD. So you have to create every time a new RDD. Whenever you are doing any operation, it will create a new RDD. Correct. So these transformations are there. The predefined transformations are there. Map is one, flat map, filter, okay, group by key, reduce by key, okay, reduce by key, join operation, union operation, okay, join operation, union operation, okay, join operation, union operations. So these all are the transformation. Now again, transformation comes like two types of transformation: wide transformation and narrow transformation. And narrow, okay, narrow transformation, like when the data is across the partition is shuffled. Data is shuffled, same partition, not across. Okay, wide transformation is data is shuffled, across partitions. Okay, then this is called like a group by key, reduce by key, join operations. So these are all wide transformation. And the data is shuffled within partitions. Okay, like I say map, flat map, filter. So you can say like when the data, different two data sets are there, definitely the wide transformation will be there. Mostly two data sets. So mostly two data sets, or we can say in the same data set, if we are doing some group by operation, group by key or reduce by key operation. Okay, because reduce by key operation apply in the same data set, but grouping is doing. So definitely there are the data is distributed across partition. So if the same key is in the different partitions, so data will be shuffled, right? Because the same key, right, in the map reduce, there is a shuffle operation, right? Because after the map reduce, map function, there is a shuffle and sort will come and then reduce comes, right? So same thing is here, where mostly two data sets are there, like a join operation. Two data sets case is a join operation. So join means like I have a one data set and I have another data set and one common column is there. But when I have same data set and when I am doing the group by key and reduce by key operation, okay, both are same, but reduce by key is faster. It is faster operation. It is slower. So I will tell you the difference, because group by key is doing shuffling first, then aggregation. This is group by key. But reduce by key is faster because it is doing aggregation for same key and then shuffling. Okay, then shuffling. So it is faster because in the same partition, if you have multiple, the combiner. So reduce by key act as a combiner. Reduce by key and combiner both are same. When the same partition you have a same key repeated, So your data will be aggregated, okay, first. But in case of group by key, it is like a without combiner. So it is not doing any aggregation. Even the key is same in the same partition, but it will not aggregate. So what it will do, it will be first shuffle the data and bring all the key together at one place, and then it will do aggregation based on that key. Okay, so this is without combiner, this is like a without combiner, and this is like a as a combiner. Okay, so did you understand first what is this transformation? Second thing comes, what are the types of transformations are there? Wide transformation, and the second one is the narrow transformation. So wide transformation again, right? Data is shuffled across partitions. So group by key, reduce by key, join. Okay, and if the data is shuffled within partitions, okay, and like map, flat map, filter, these are the narrow. Okay, and if I come to difference between the map and flat map, okay, so map is basically doing one-to-one operation. Okay, if I say I have RDD of 3 element and I want to multiply, of each element of RDD by 2. So can you tell me how many elements will be written in a new RDD? How many element will return? How many elements will be returned in new RDD? If I do 3 element are there, just I'm assuming it, my 3 elements are, one element is 1, second is a 2, and third is 3. So how many element I will get it after multiply of 2? It will become double, or it will become same, or it will be nothing will return. Just think, I'm saying already one-to-one operation. Understand this part, one-to-one operation. What is meaning by one-to-one operation? Like this 2 you are multiplying on 1 and you will get value 2. If you do multiply of 2, then you will get the value 4, second element of RDD. And when you multiply 2 with 3, you will get 6. So any other element is there here? No, right? So 3 elements you took, multiply of 2 you did, and again you got the same number of elements. That's your map. Is it clear? Because map is returning the same number of elements. It is doing one-to-one operation on each element of RDD or data frame and giving you the back to the same number of elements. That's basically map. Okay, because very simple definition. If you understand definitions clearly, you can explain very well in interviews, because mainly the fight is in interviews is we are not able to explain with the examples. Okay, and the interviewer thinks, right, you are practically or you have not done, right? So when you want to show that practically, like, nobody's asking to write code, because every time it's not possible write the code and then check someone to you, right? Like you are practically hands-on or not. Okay, because when you are explaining your concept in a practical manner, right, so that is also a sign like someone is understanding you are really a practical hands-on guy. Okay, so that is the reason everything you learn practical way, even theoretical things you are telling, just say about practically. Okay, because nobody has time and nobody checks like everything, like you will write a code. Okay, sometimes they'll ask you write code, especially that is a separate coding, live coding sessions, and they will ask you write the code, some Python code, SQL code, right? So that is particular specific thing, but every theoretical question they will not ask you write code. So that's your responsibility, like you speak more practical oriented manner. Okay, so flat map is, when you're talking about the flat map is other hand is doing one-to-many operation, right? Take a one element of RDD and create a more than one element, right? So more than, so it is doing one-to-many. So it is a relationship, right? Just say one-to-one relationship or one-to-many. Very, very easily you can remember. Map is one-to-one and flat map is one-to-many. So take one element of RDD and produce more number of element, more number of elements in the RDD. Okay. So here, so definitely it is true. If your RDD has 3 elements, so you will get more than 3, right? That is the reason it's flat map. Why it is called flat map? Flat map is basically doing a flattening of the data, flattening of the data. Okay, that's the reason it is called flat map. So flattening of the data, I say, suppose I say I have a array of, I say I have a 3 sentences there. Okay, so this is my first sentence. Okay, and the second sentence I say in my array, this is my second sentence. Okay, and I say I have a third sentence, this is my third sentence. Okay, just I'm taking an example. So how many total element of this RDD? If I see in this list, right, this is a list, right, square bracket list is there. How many element is there? If I calculate the size, right, if I want to find the length of this array, what will be the length, right? What will be the length of this array? Are you guys not getting interest, or you are feeling boring? Like, you can tell me frankly. Okay, see, I want interaction. Okay, see, I want to know whether you are understanding or not understanding. You have any problem, you have any question, you can ask me. Okay, because because every day I will ask in the beginning of the 10 minute, I will ask questions. Okay, because I don't care like if you join or not join. Okay, because I want to give the feedback and I want to give the real feedback to the employee. Okay, because I want to know those who are really seriously studying, right, every day and giving answer and becoming interactive. Because whatever I'm explaining, I'm asking the question from there only. I'm not asking very different things, or I'm not asking the question not related to here. Anyone cannot tell how many elements are this in this array?
3.
3.
Yeah.
3 elements.
So 3 elements is there. Okay. So 3 elements are there. So I'm taking a first element and I'm applying the flat map. So what flat map will do, it will combine all these elements of the array. All the elements, it will make a one single array. Okay. So flattening means, flattening is here to make combine of all strings elements into single array. Okay, this definition is very important, like this kind of answer, because if you are not using the flattening word while speaking about the flat map, so nobody will understand. Into single array. So after applying the flat map function, suppose you are applying flat map, FLAT, flat map. So then after, when you apply the flat map, you will get a one single array, and that array will have your all the words. Okay. So, but that will become a RDD, okay? Because you are taking input as a RDD when you apply this array, when you pass this array to the parallelize function. So I will show you how to create a RDD from the array, because this array is a general array. This array is a general array, right? Just a list, right? It's a Python list. But when I make it, when I use this function, right, sc.parallelize, when I pass it this array like this, right? Now it will become RDD. So RDD is again an array of element, but it is distributed. It is immutable. It is parallelized. Okay. So this RDD is a like Spark understand RDD. Spark doesn't understand this list. Spark understand RDD. And when you are making it any collection, if you pass it to the parallelize function, then it will become RDD. Okay. And RDD again, you can convert into the data frame. When you have a schema, you know the number of columns, then you can attach the schema with RDD, then your data frame will create. So I have told you yesterday how many ways we can create RDD. So this is the first way of creating RDD. So RDD can be created by the parallelize function. That is a one way. And second way of RDD is reading some unstructured data, right? That is text file, unstructured data text file, right? If I say the example of this entire file is a unstructured and there is no fixed column, right? So this kind of file, if you are reading, write this sc dot read dot text file, and then you give the file path, and then this will be giving also RDD. So this is also RDD. So you will write RDD1. Okay. So this is also example of RDD. So two ways, like one is you are creating RDD by making a parallelize function. Second way of getting the RDD is when you are reading a text file data. Okay. Okay. I'm not talking about the CSV JSON, because when you are reading a CSV JSON, Parquet, Avro, all these files will be giving you the data frame, not RDD. Okay. RDD will be some text file data which is not having fixed column, that will be giving you the RDD. Okay. So now I was talking about these are the two ways. Okay, I cut it here. How many ways? To create RDD in Spark? Okay. So this is your answer. And when I say flattening, so all these words will come in a single array after. So new RDD, this is a new RDD. I will say this is array RDD. This is a new RDD variable. Okay. And this array RDD will have all the words in the single array. So all words means this will become all comma. So what is the advantage of keeping RDD in a single array? The advantage is
Should we
like
use dot flat map for this?
what?
To do this, should we use dot flat map
Yeah,
function?
that I will show you. That's yeah. After doing dot flat map only, if I first I will read the data, some file. After getting RDD, I will do RDD dot flat map. Then I will get this single array RDD. Okay. This is also RDD. Okay. So this RDD, why I'm making it all the element in a single array. Word count will be easy, right? Because no matter from where the data is coming, no matter, right? From this sentence or this element, where it is coming, no matter. Because when you keeping it all element in a single array, then you can do the aggregation, right? Based on the key. Okay, first, how many time is there? Is how many time is there? 3 time is there. My is how many time is there? 3 time is there, right? So then I will show you that code, how to do word count on the RDD. Okay. So just I'm talking about first basic transformations, right? Understand like what is a map, what is a flat map, and flat map is doing the flattening of the data and creating a one single array with more number of element present in the existing RDD. Okay, present in the existing RDD. So wherever you are applying the flat map, you will get the more number of element from the existing RDD and data frame. Okay, so that is your flat map. Okay, it's clear. First is transformations. What are the different transformations? What are the what is a flat map? What is a map? What is a filter? So these are the transformations. So filter is basically filtering the data. Just you are reducing the data, right? Based on some condition. Okay. If I say in this particular RDD, if I apply the filter, what filter I can do here? Suppose what filter I can do? I can say filter, I say lambda x, I say x, I say dot len of x, I say is greater than 3. So what filter it means? After that, you will get another RDD. So what it will means? Like where the length is greater than 3, only those word will be going for the next operation. So this will go, this go, this go, this go. Wherever 2 length is there, or those words will not go. Right. So this kind of filter things you can apply. Okay. It could be any filter. I say I want to get only the word which is starting with the F letter. So start with we can do. Okay. So X dot start with like I can do F. Okay. So you can write anything. The condition is all depend on us, like how can we do. But again, filter is doing on each element of RDD. And if it's checking whether the condition is matching, then it is bringing to the next one. If condition is not matching, so it will filter out. Okay, it will remove it. Okay. Okay, so now I show you the practical. Okay, so this is clear so far. We have not we have not done the any join and any group by reduce by key. So simple we have done. Okay. So this is the one project. Okay, this PySpark by example project is there, and this project has all the source code. Okay, so the GitHub link is this project PySpark by example. PySpark by example. This is the source code. This is the GitHub link. You can find here the github.com. I'm giving you this GitHub link. You can check out this GitHub link. Okay. So how to check out this code? So you simply what you do, you you go here and create a new project or import a new project. So then you will get new project, version control. Okay, it is creating a new project. So you know, right, how to configure the Python thing here. Just you have to go to settings. So Git is there. So if you want to import the project, so uh,
Arvind, just a request.
hmm,
To enlarge this term, I mean this thing, it's very small.
this source code.
No, I meant to say the wordings, font size.
Okay, this font size. Let me check. Okay, this is the virtual machine. There is appearance setting is there. Actually, bottom is taking time. Okay, meanwhile, I show you the like how we can do the transformation things. Okay. Okay, so this is my Spark session. Okay. So I'm going to read. So I will create a RDD. Okay, so any file we take example. Okay, so we take example in our home directory. Okay, this file name is hello.txt. Hello.txt. If I do only hello.txt because I'm in the same directory location. So we can read the file from the local file system or Hadoop file system. Okay, if I do rdd.count, so it is giving 2. So how many rows are there? So count is the action because I'm not doing any transformation. Directly I called the action. Okay. So in the Spark is this font is fine. This one. Is it visible to everyone?
Yeah, this is better. Yeah.
So when we are reading RDD, when we are going through the data, right? When we are getting the data, so we have two options. Either I will do the transformation or action. But the problem is transformation you cannot directly trigger because when you call action, then the transformation will be triggered. Okay. So if I say I'm going to do RDD, this RDD dot map, I say, and then I will be used lambda x, and each element of RDD I want to give 111, right? So generally in the word count, what you do the word count when you do x comma 1, you do, right? You remember in the map reduce, right? And when I do collect, when I call the collect here, this collect is basically calling a action. Okay. If I don't call the collect, you can get the object. You are getting the object, right? But you are not getting the final result, right? You are not getting the result, right? Okay, what is basically this transformation date? So if I call collect, so collect is a basically action, and what action is doing? It is applying the map element. So what it did map element? Here it has done each element is one because you already know map is apply each element of RDD and applying the one. So is it a correct thing? I should go map or I should do something else, like I should get all the word like 1111, right? Because here I'm getting my sentence is the one, but I want hello comma 1, I want how comma 1, r comma 1, u comma 1. How can I get it? So what do you think, like before this map? Definitely map will apply because map is giving each element of RDD and return the same number of element. And then we can do x comma 1. Okay. But before this map, what we should do? What do you think? Like I
We
have a
can use
two
split.
sentence.
We can use split.
Split. Okay. Split will be giving you array. For the one, you will get array separately, and one array you will get here. Again, you have to join the array, right? What easier thing is there? Like if I have a two elements, two
Flat,
element as a sentence as a array, so you can combine it. I told already.
flat map. Yeah.
Flat map. Yeah. So RDD dot flat map you will apply flat map. Okay. And then right, lambda you have to write, right? So lambda keyword. So lambda. So here is only one element you are taking at a time, right? So what you will be doing, split, you will do x dot split. So definitely split we have to do because we have to split by the space. Okay. But I have to apply this operation automatically. I should not do split one by one manually. So one operation is you can do manually one by one operation, but instead of manually one by one, I want to do it automatically by flat map. So I will be giving here rdd.flatmap lambda x, and each x I will split by space or // s, that is for flat map, thus split. And after that, what result should come if I do collect? What will be coming after this? All elements will come in a single array. What happened? I think I have not closed here this bracket. Okay. Can you flat map RTD? I think this space is not working. Can you see this? If this is not properly working, what is the problem? It didn't apply. So is it coming as it is, right? But here, when your space, and if I give no space, then what will happen? And you know what will happen? You will get the error, and otherwise we will get a single character also. But here we cannot do what I clear. This is okay. Let's see if this helps. So this is giving the me as a all element in a single array. Now what should I do if I don't apply the collect? Because collect I'm just going to check my result. If I don't do the collect, now next what I should do? Map, right? Same thing what I did last time. Map lambda x comma 1 x comma 1, right? Okay. Now if I do collect now, I will get each element 1 1 1 1, right? So now we have done the second step. The first step is we have read the file. Second one, we have applied the flat map. Then we have applied the map. Okay. And now the next what is possible? Like we have to do aggregations, right? So keys together, we have to combine the keys together, right? So all keys together have to combine, right? Wherever, right, hello is coming multiple time, R is coming multiple time, or is coming multiple time. Okay. So we can do reduced by key. So reduced by key, and here we have to use lambda with x comma y. Lambda x comma y. Why we are taking two? X comma y, because we have to do aggregation, joining we have to do like aggregation, sum, count value. So x plus y reduce by key, and after that I will do collect. So here is the case, all the word are single word, right? So that's the reason even if you do reduce by key, it will not aggregate, right? Because here all words are like 1 1 1. Okay, if I just do some repeated copy,
Can't we use group by instead of reduce by key here?
group by key we can use, but when the data is repeated more number of times, so your performance will be degraded. If the data is not repeated, both will be same. There is no difference in the performance. So group by key also same. I will show you. So if I save this file, okay, because group by key is not doing aggregation first. It is doing shuffling first. Okay. So your all data will travel, right? If I say R is coming 5 times. So in case of group by key, it will shuffle all R comma 1, R comma 1. But same thing if I'm doing the reduce by key, so r comma 5 it will become 1 plus 1 in the same mapper, right? So that's the same logic like we have seen in the combiner. That's the reason I like taught there the map reduce, right? So map reduce concept will come here with a different name. Okay. So if I'm using here group by key, I'm just changing here, but I have to read again the file because I have changed in the file. So I want to read again file. After that, now I can do all these operations. So instead of reduce by key, I use group by key. If you want to persist this result, you have to group by key. You have to define, you have to take it in the RDD. Some new RDD you have to take it, RDD1, but don't use collect. Later on, you will be apply the, you can use the apply collect. Okay. This is group by key is giving issue. We took it RDD already. Group by key. Group by key. Group by key is giving issue. Group by key is correct. Is there some other issue is saying group by key. This is the group by operation. So x dot sc dot parallelize. Okay. Then group by key. Okay, okay. Group by key is not taking, but this is Scala code. Okay, this is files permission. Okay, so group by key. This is again Scala group by key. So it is making a pair. R is comma. All word is coming single word, right? Here, right? If you see there is no aggregation is there, right? But if the same thing, if I do with the reduce by key, if I apply If you group by key doesn't take parameter, reduce by key, and I do dot collect. Okay. And then I say rdd1 dot okay, this one don't need to assign. rdd1 dot. So if you see this time is, it is doing aggregation. So here you can see the difference, right? Here is the value is not coming, but here is, this is each individual element, like it's not doing aggregation. Okay, so we have to do like this one. After this, like some map operation and some operation, then we can do the collect. It is doing. Okay, so group by key is not better choice when you have the repeated data. When you have repeated data, go with reduce by key, because it will be giving faster, right? Like performance will be better. Okay, so that is the reason we prefer reduce by key. It's clear, right? Group by key and reduce by key both are doing aggregation based on the key. So this part is a key, and this is a key value pair. This is a tuple, right? This is a tuple. This is a tuple, key value pair tuple. And this tuple, like we are doing the transformation. So when we are applying map, flat map, and then we are doing reduce by key. So in the key is aggregating. So all this together and making it count 3. All hello, the count is 3, right? Okay, so this is clear.
Yes, sir.
Okay.
And one
Hmm.
more thing.
Hmm.
Reading the data will be considered as transformation or action.
Reading data, you are saying it's not an action, right? It is a transformation only, because you are reading, right? RDD. Actually, it is not category of the transformation, because I will say, like when you are creating a RDD by reading data, right? Because once you do RDD, right? Once you have RDD, because that process we cannot say RDD. Process, we are saying whatever is output is coming of any operation, that is called RDD. So I say the first RDD is when you are reading the file, right? Like when you read the file and get the RDD, right? The result, right? Where you are storing, that is RDD. So your RDD is this one. This is the RDD, right? Okay. So you can say, like when you are doing any reading operation, right? When you are reading file, okay. So you are getting end result is a RDD, that you can say, okay. Okay, but when you are doing any operation, now you are doing flat map. This is the one RDD to another RDD you are creating. Here, one RDD to another RDD you are creating. But here, you are doing inline operation. These are called inline operations. You are not storing somewhere. Otherwise, you can create different RDD, right? So I'm not creating a intermediate variables. I'm not creating, because it is no use of creating multiple variables, right? So I don't need to create. Okay, so intermediate variables I'm not creating. So this is called inline operations. Okay.
Thanks, sir.
Okay, so tomorrow I will cover this other joins things. Okay, and this one just go through once the code. Okay, I'm saying just RDDs one you go through. Okay, wherever you are getting the RDDs one, so here you will get these are from here to here. These are all RDDs one, RDDs. So you can just reduce by key. RDD one is there, right? Okay, so go through this one. Okay, this is also having word count also, like you will get the example. Okay, so tomorrow I will cover the data frame operations, and I will cover the other RDDs operations: left join, right join, inner join, self join, cross join. Okay, so this is, and filter operations, right? How to do filter. Okay, okay, I'll cover tomorrow. Okay, thank you.